Children, in this video we are going to learn about conversion of galvanometer into an ammeter. Already you know that in the last class we have studied that in moving coil galvanometer it is used to detect current, right? It is simply used to detect current in an electrical circuit. You cannot measure the magnitude of the current. You do not know the value of, you cannot measure the value of current using an galvanometer. So to measure the current we need ammeter. Okay, so galvanometer is converted into an ammeter. So ammeter is used to measure the electric current in an electrical circuit. How will you convert galvanometer into an ammeter? That is by this method, right? How galvanometer is converted into ammeter? By connecting low resistance in parallel. Okay, this is galvanometer, ammeter, low resistance, parallel. If you connect a low resistance coil, okay, which you call it as shunt resistance, if the low resistance coil is connected parallel to the galvanometer, then this setup we call it as an ammeter. Okay, the low resistance coil which you are connected to parallel to the galvanometer, we call it as the shunt coil, otherwise shunt resistance. If the total current total current in the electrical circuit is I, if this current is passed through the galvanometer, you know galvanometer is sensitive instrument. If the total current passes through this, the entire PQRS, that copper coil, it gets burnt up, right? Only it is sensitive and it can allow only minimum current, say around 1 milliampere current for full scale deflection. It is enough. So total current is split into branched here at this point. You can see IS and IG. I is the current, shunt current, which passes to the shunt coil, okay, and the remaining current passes to the galvanometer, right? Now so how you are converted galvanometer into an ammeter? By connecting, galvanometer is converted into ammeter by connecting low resistance coil in parallel, okay, parallel to the galvanometer. You have to note down this point, children. Now you know this IS value. To find out IS value, you can apply Kirchhoff's first law, children. You know that, take this to be the junction, let it be the junction. You can see the current I passes through the junction, whereas IS and IG, shunt current, galvanometer current, is away from the junction. So if you apply the first law, you can see current toward the junction is I, that is equal to IS plus IG. Okay, current going out of the junction. So from this you can find out IS. So IS is I minus IG. So what is the IS value? I minus IG. So how will you convert galvanometer into an ammeter? Galvanometer is converted into ammeter by connecting low resistance in parallel, right? This low resistance we call it as the shunt coil, shunt resistance. And already you know that this ammeter is calibrated in ampere, right? So ammeter range, it is determined by the shunt resistance. What I mean is, this range of the ammeter, few ammeters can be used to measure milliampere, and few ammeter can be used till microampere, and some ammeter can be used till 10 ampere, 20 ampere. So this ammeter range is determined by this value of shunt resistance, right? Shunt resistance determine the ammeter range. Now we should be familiar with this. What does this each letter represent? Okay, now what is I? I is the total current in the circuit. IS is the shunt current. IG is the galvanometer current, and RG is the galvanometer resistance. S is the shunt resistance. Already you know that I is equal to I minus IG. From Kirchhoff's first law you have got this. I is equal to I minus IG. So when galvanometer and shunt resistance are in parallel, right? Already you know that galvanometer and shunt resistance are in parallel, right, children? Look here, look at this diagram. You can see galvanometer and the shunt resistance, both the resistance are parallel, right? In parallel connection, you have learnt in second lesson what is common. Potential is common, right? So when galvanometer resistance and shunt resistance are parallel, potential is common, right? What I mean is, galvanometer potential and shunt potential are equal. So to find the value of V, you are going apply Ohm's law, right? So what is the current in galvanometer current is IG. Galvanometer resistance is RG. Already you have written this. Look here, children. Already you have noted down. Galvanometer current is Ig, galvanometer resistance is Rg, right? Same way shunt current is Is and shunt resistance is Es. So you can write shunt resistance V, voltage across the shunt is shunt current Is and shunt resistance is Es. Okay, Is value is I minus Ig, and if you rearrange this, and the value of shunt resistance S is equal to Ig into Rg by I minus Ig. You consider the same expression, children, and you are going to take this expression, consider this expression, and you are going to prove that that is deflection of galvanometer and the current Ig, galvanometer current, are directly proportional. Okay, consider this experiment and you are going to arrive this fact. Deflection in galvanometer and galvanometer current are directly proportional. Okay, you will start with this expression. Ig Rg is equal to I minus Ig into S. Right? You remove the bracket and you bring this I minus Ig S to this side, to the left side, and if you rearrange this, Ig you take it commonly out, so you will get Ig into Rg plus S is equal to Is. From this, if you find out Ig, what you will get? S by Ig is equal to Is by Rg plus S, right? You can see all these are constant. S, shunt resistance, galvanometer resistance are all constant. So remove this constant and put proportional sign. Okay, so Ig is proportional to I. Okay, already from in galvanometer answer you have learned that deflection in galvanometer is proportional to current. Now you compare these two equations. If you compare these two equations, you can say that theta, compare these two equations, you can say that theta is proportional to Ig. Okay, so deflection in galvanometer is directly proportional to galvanometer current. And already you know that galvanometer resistance and shunt coil both are connected in parallel. So to find the effective resistance, we are using this formula. Already you are familiar with this, right? 1 by Rp is equal to 1 by R1 plus 1 by R2. This you have learnt in second lesson. So to find the effective resistance, you can use this formula. 1 by R effective is equal to 1 by Rg plus 1 by S. Now you know that initially you have told that shunt resistance is very low. Okay, very low resistance. Shunt coil is having very low resistance. So the ratio S by Rg will also be very low. As a result, what happens? The resistance of ammeter will also become very less. Resistance of ammeter will become less as this ratio and this S value are all low, right? Less, I mean. So we can connect ammeter in series in an electrical circuit. What I mean is, whenever you are going to use this ammeter in a circuit, you can connect it in series in that circuit. Already in 10th standard you have done Ohm's law, verification of Ohm's law, right? So if you could recollect, this is the circuit diagram you have used. Battery, key, rheostat, resistance, ammeter, all these are connected in series. Across resistance, voltmeter is connected, right? You just recollect this. How is this ammeter connected? You can see that ammeter is connected in series with the battery, right? So what I mean to say is, ammeter is always connected in series in an electrical circuit. If you connect it in electrical circuit in series, you know that this is having very low resistance, so that the current or resistance in any part of the circuit will not be affected, because this is having low resistance. Ammeter is having very low resistance, so that in any other part of the circuit these two values, current and resistance, are not affected, right? So we can connect ammeter in series in an electrical circuit, so that current or resistance will not be affected in the circuit. This you need not draw, children. For reference I have given this. And the next point you have to note down is, ideal ammeter has zero resistance. Ideal ammeter, that is, this is theoretically only possible, right? Practically no resistance is having its value as zero. Ideal ammeter has zero resistance, right? So current, next point you can write, current measured by ammeter in a circuit always shows a value less than actual current. What I mean is, if this ammeter is going to record some current in the circuit, the value it shows is not the actual value. Actual current in the circuit is not shown by this ammeter. There will be always an error, right? There will be always this ammeter reading is always less than the actual current. Okay, so you can say current measured by ammeter in a circuit is always shows a value less than the actual current. So we go for the percentage error. What is percentage error? Delta I by I into 100% is equal to I ideal current minus actual current by ideal current into 100%, right? And the last point is, if you want to increase the ammeter range n times, for example, you are having an ammeter of range, you can measure 1 to 10 ampere, right? If you are able to measure 1 to 10 ampere, that particular ammeter, right? If you want to increase its value, if you want to measure 1 to 20 ampere, right? You want to increase the ammeter range twice you want to increase, right? So for that you have to think about the coil, that is the shunt coil resistance only determines the ammeter range. Okay, to increase the ammeter range n times, you can use this formula. S is equal to G by n minus 1. Shunt resistance, galvanometer resistance, this is the time, how much time you have to increase the range, ammeter range n minus 1. Using this formula you can choose the shunt coil, resistance of the shunt coil, right? So that you can increase the ammeter range n times. So totally I have summarized 16 points. This might be a 3 mark or 5 mark question, children. I hope you understood. Learn thoroughly. Thank you.